Alright, this is for my tutorial on analog outputs, and within the code for that there is something called serial.parseFloat, float being a data type, I think. So I thought I would start with that, just reading the definition from the Arduino website. Serial.parseFloat. Description: serial.parseFloat parenthesis returns the first valid floating point number from the serial buffer. Parse_float is terminated by the first character that is not a floating point number. The function terminates if it times out. See serial.setTimeout. Serial.parseFloat inherits from the stream utility class. Syntax: serial.parseFloat, serial.parseFloat look ahead, and then there's this look ahead ignore. Parameters: serial port object. See the list of available serial ports for each board on the serial main page. Look ahead, the mode used to look ahead in the stream for floating point numbers. Well, I think maybe I will stop there. Alright, so according to some reading I have done, a few of the digital pins, 3, 5, 6, 9, 10, and 11, can offer variable output other than just 5 volts or 0 volts. These have a PWM tilde, as I've heard some people call it, beside each of the numbers 3, 5, 6, 9, 10, and 11. That stands for pulse width modulation, which means the amount of power at the output, and this is achieved by turning the pin on and off rapidly. And according to some reading, some of the pins differ. So apparently all of the pins except 5 and 6, so not 5, not 6, not 5, and not 6. Okay, all of the pins are 500 pulses per second, whereas 5 and 6 provide, I'll get my brush. Alright, so here I am going to explain the code line by line. This is for analog outputs. So again, that's for pins 3, 5, 6, 9, 10, and 11. Const int called outPin or output pin equals 5, and in the void setup, pin mode sets up pin 5 as an output pin. Serial.begin sets up the serial monitor. Serial println, please choose the voltage or the volts between 0 to 5. And in the void loop, if serial.available, so I suppose it just hangs there waiting for user input, and once it's entered, that information is accepted as a float, or rather a float type data type is created here as a local variable, and it's called volts equals serial.parseFloat, which hopefully I covered already. And then another local variable called int PWM value is created, and it's defined, or it gets its value from the volts variable, which was entered by the user, and that is multiplied by 255 and then divided by 5. And I've seen this many times in Arduino sketches, and this basically maps out the value, and I forget the full explanation for that. Anyway, analog write, the function, is used to go ahead and set the value of the output pin or out pin, which is pin 5, and it takes its value from this calculation, which is PWM val, which also requires the user input for the volts. So here is the serial monitor, and values can be typed in between 0 to 5.
Alright, this is pretty cool how this works. This is according to the code that I covered, hopefully already. Pin 5 is sending a signal out, and it's connected to the multimeter lead, and there's a ground line attached to the other multimeter lead. And here is the serial monitor and the applicable code. So if I type in 3 and hit enter, the same value should show up on the multimeter. And it does. And I'll enter in 2 again. Okay, now let's try 2.5. And 4.9. 5.2, see what that does. That's what happened. 0.9. Let's try that. 0.1. What about 0.01? 0.05. Alright, so rather than the multimeter, I thought, well, let's just hook it up to the LED and see the different brightness change. So I might as well start in order. Currently it's being sent 0 volts, so how about 0.1 volts? That's 0.1, 0.5, 1 volt, 1.5, 2, 3, 4, and here's 5. It's almost hard to detect. There's 5, 4, 3, 2, 1. 0.5, 0.1.